Good morning, students. Today we are going to learn a new chapter. That is our second chapter. The name of the chapter is Motion in One Dimension. So, the word itself is heard. It is about a motion or movement. So, let us try to what are the terms related to this motion concept, and also what we will try to understand what is one motion, one dimension motion, two dimension motion, and three dimension motion. So the main topic first of all we come to handle with is physical quantities. So what are physical quantities? Physical quantities are that which can be measured. Okay, the quantities that can be which can be measured. For example, you say in around us we can see different things, different objects. So that is having some sort of weight, some sort of length. Okay, so those things that can be physically measured by a unit is called physical quantities. So there are basically two types of physical quantities, and the first one we are going to deal with is scalar quantity. So what are scalar quantities? Scalar quantities are those physical quantities which are completely described by their magnitude only. Okay, so physical quantities which are completely described based on their units. So for example, length 10 meters. So we don't say that it's 10 meter in which direction. So mass 10 kg or 5 kg. We don't say 5 kg in which direction. No, we don't say that. So scalar quantities are those physical quantities which are completely described in their magnitude alone. So there are certain parameters or certain ways to express a scalar quantity. So basically there are two things. The first one is that the unit in which this quantity is being measured. Okay, so you say length we have meters, mass we have kilogram, time we have second, etc. So the second uh, parameter is that the numerical value of the measured quantity. So along with the unit we get a numerical value. So if, for example, if you measure a distance, you get 1 meter. So the 1 is a numerical value, and always remember that the scalar quantities are written symbolically with its English letter. Just simply their English letters are written. Those for the scalar quantities. For time it is T, mass it is M. Okay, now let us see an example. So here it is 13 seconds are written by 13s. So where the 13 is the numerical value, or we can say it is a magnitude of that quantity, and s is the unit. And the same way you see 10 kg, where the 10 is the numerical value, or you can say the magnitude of the quantity, and kg is the unit used to measure that quantity of physical quantity. Okay. Now let us see what is scalar vector quantity. Vector quantities are those quantities which are completely described by both magnitude and direction. So you see, first of all we see that point. So physical quantities which are completely described based on both two things. One is their magnitude, the other is their based on their direction. So what is the peculiarity? That they have their own addition rules. So they are added or subtracted or divided or multiplied based on their own vector rules. Okay. So for example, displacement. So displacement you will learn further in the coming point classes. And for example, I will say displacement is the shortest distance between 2 points. It can be either positive or negative, or in direction, positive direction, negative direction. Okay, it can be sometimes zero also. Okay, you will learn velocity in the one direction, in the opposite direction. Force also one direction, in the opposite direction it can happen. Okay, so the same way as scalar quantities, there are certain parameters to explain vector quantities. So there are three parameters basically. The first one is about its unit. So the unit in which the vector quantity is being expressed. And the second one we see it is a numerical value. Just the first two are just same as the scalar quantity, but the final one is something different from the scalar quantity, that is nothing but the direction. So the direction is the important part in the vector quantities, but that which separates it from the scalar quantity. Okay, is that clear? I hope so. It is very much clear the difference between vector quantities as well as the scalar quantities. So this is a basic. From this we now develop all other topics related to it in this chapter. Okay, so now let us see. The vector quantities are generally written in English letter, but what is the specialty is that always either they have an arrow on the top of it, or it sometimes it may be written as bold letters. Okay, there are two types we write. First one is either they may have arrow on the top of it, or they may be written in the bold letters. So for say example, so velocity is denoted by the letter V, and it is either we write small letter V bolded, or you say V with arrow on the top. Otherwise you say acceleration, you say A or an arrow on the top of the A. Okay, so now you see, for example, consider a box is pushed in one direction with a force of 10 Newton is applied. So how do we write? We represent it as 10 Newton N with arrow on the top, or we simply write 10 bold N. Okay, so if it was consider if it was pushed on the opposite direction, so how do you write? So we write it as minus 10 Newton with the direction on the arrow on the top, or we bold it. So negative direction is also there, a positive direction is also there in the case of vector quantity. So now what are certain other related topics with respect to scalar quantities and vector quantities? Okay, the first topic we see is rest. So an object is said to be at rest if that does not change its position with respect to its surrounding. So what is rest? Oh, we take rest every day, we lie on the bed and sleep. So how do we understand that we are taking rest? So when you lie on the bed, with respect to the bed, we are not moving from the position of bed to any other position. So we are always in that position. So that is why we say we are at rest. Or with respect to the room, you are always still in the bed. Okay, with respect to the room, you are always in the bed. That is why you are said to be at rest. Or if somebody comes and looks into your room, so you are lying in the bed for some time, for a time period, and you are not changing from there. So you are considered to be at the position of rest. So it is basically based upon the position as well as the surrounding. Okay, now you see an object is said to be in motion. The concept of motion is coming here. So if it changes its position with respect to its surrounding. So let us say while we are driving a car. So at one point we were at one junction. So after some time interval we have reached another junction. So with respect to somebody outside our car, you were at a time point A at one junction, and now at time point B, somebody outside, you are at another junction. So you have changed from position A to position B. So with respect to surrounding, you have been moved. So that is called motion. So I hope this topic is clear. So now we let us see. State of rest and motion are purely relative. Okay, you will learn in the higher classes why it is so relative, because it is basically based upon what? Two things. It is based upon the observer, or the one who is outside viewing you, and the second part is then in the surroundings. That surrounding, in relation to the surrounding only we understand that whether it is regarded as motion or rest. Okay, now when a body moves along a straight line path, the motion is called one dimension. So now we are going to learn the basic concepts of dimension. So when a body moves in a straight line, so you consider the example. So you see a car is moving on a straight line. So there is only one direction, one side. So that is called motion in one dimension. So now let us see what is motion in two dimension. So if body moves along a curved path, so if you see there is a curve, and if a car is taking a curve, we can say that it is two-dimensional motion. Okay, so now let us see what is third. If the body moves in a space, it is called three-dimensional space. Okay, three-dimensional motion. So for example, we can say if you take an object, a sphere, we say sphere, and it is moves, then it is we can say that the both movement of the sphere is in a three-dimensional motion. Okay, so is that clear for you? So now what are the other basic concepts related to the quantities, physical quantities? So the next topics come is distance. Distance is the length of the actual path covered by an object in a time interval. So you see, distance is the length of the actual path covered by an object in a time interval. So let us consider that. So we are traveling from point A to point B. We may be traveling in a straight line or in a S shape, or we may be traveling in a parabol shape, or any path you take. So the path that you take is the actual path that you covered, right? So either you walk straight, or either you walk in S shape, or you walk in parabola shape to reach the distance B. So the path you took, so the path you took, or you path through which you walked, is the actual path you covered, right? So that is called distance, and it is dependent upon a time interval. Okay, so it is a scalar quantity, and the SI unit is meter. Okay, we have to remember the unit as well as what type of quantity it is. Okay, then only in the coming classes it will be easy for you to understand. Now you see, the next point is displacement. So displacement is what? It is the shortest distance between initial and the final positions of a moving object. Okay, it is the shortest distance between the final and the initial position of the object. Okay, so it is a vector quantity. Why it is vector quantity? Because it is based upon the direction. Okay, so distance is never dependent upon the direction, but displacement is dependent upon the direction. Why it is so, we will understand. So the SI unit is meter. You see, I have given an image. A boy or something is traveling from the point A to B. Okay, earlier we see the distance means it is a distance traveled from A to B. Either it can be straight line or the blue path. So that is, distance is a path covered. It can be either straight line or it can be the blue path. But displacement is what? Displacement is the shortest distance between A and B. What is the shortest distance between A and B? It is the straight line, not the blue path. So the S-shaped path takes more distance than the straight path. So the straight path is the displacement here. So and this, it has got a direction also. Okay. Is that clear? I hope the displacement and distance is clear. Now you see, displacement and object is in a given time interval can be positive, negative and zero. You will understand. So if it was from A to B direction, it will be positive. If it was from B to A, then it would be negative. Okay. So in a closed path, the displacement is always zero. Okay. So if object moves on a closed path, displacement for the travel on a closed path is always zero. But you see, only the displacement is zero, but the distance traveled is there. It is not zero. It is more than zero always. So displacement can be zero, always zero on a closed path, but not the distance. Okay, the difference you should be remembering. Okay. What are the difference between distance and displacement? So let us see first what are distance. Then let us compare with displacement. So distance is the length of the path covered by object in a certain time interval. So I so told you know it can be straight line or any direction you can take walk. Okay. So that but it is the actual path that you go through, not the shortest. It is the actual path that you take, and it is a scalar quantity, and it has got only magnitude or the value of the quantity, and it always depended upon what the object the path taken by the object or the man or whatever the thing it is. Okay, so we follow the path that is followed by the object, and it is always positive, and it cannot be it can be more than or equal to the magnitude of the displacement. Always remember that it is always more than or equal to, okay, of the magnitude of the displacement or the value of the displacement. And sometimes you have to remember this point, it may not be zero even if the displacement is zero. In a circular path you see, in a closed path you say displacement is always zero, but the distance, there is some distance that is covered, no, in the circular path also. So there is distance, but it cannot be zero if the displacement is not zero. Okay, if there is some displacement, there is surely there is this distance also. Okay, so you remember the 6 point, little bit confusing, I will explain. It may not be zero even if the displacement is zero. In a circular path or closed path, see displacement is zero, but there is distance. In the same way, if there is a distance, if there is displacement, that means displacement is more than zero, then there is definitely distance. It cannot be zero. Okay, now you see the displacement. It is a distance traveled by an object in a specific direction in a certain time. So it is a distance traveled by the object in a specific direction in a certain time. So it can be explained otherwise that it is the shortest distance between final position and the initial position. So it is clear. So the displacement is a vector quantity, and it has got both magnitude as well as direction, and it does not depend on the path followed by the object. You see, we saw the example that it is the shortest distance between. So you may be walking in a zigzag shape, but the shortest distance between may be straight line. So though you walk the zigzag, but the displacement is always the shortest distance, that is a straight line. Okay, so it doesn't depend upon the path followed by the object. So it can be what? It can be positive or negative depending on its direction. Okay, so whether it walks straight, the displacement is on the straight or it is in reverse direction. So it is based upon it is positive or negative. And fifth one is that magnitude can be less than or equal to the distance. Okay, that is the important point. So you see, displacement is always can be less than or equal to distance. Always. It cannot be more than distance. So it will not be displacement. If it is more than distance, it will not be a displacement. Because the definition says that it is the shortest distance. Okay, so you remember it is the shortest distance. And also you see, it is zero if the distance is zero. Okay, if there is no distance, there is no displacement. Okay, it can be also zero if the distance is not also zero. Okay, so in the closed path there is some distance, but there is no displacement. I hope this is very much clear for you for the distance and the displacement. Dear students, now we are going to deal with the next topic, that is speed. Speed is a distance traveled by an object in an unit interval of time. So you see, speed, we know every object has some kind of speed. Okay, how do we understand there is speed? So if you take an object, okay, let us take a bike. So a bike is traveling from one direction. from one point A. So at given time 1 t1 it was at the point A. So after some time t2 when you look it is at another point B. So it traveled from A to B at a time interval of t1 to t2. So that distance traveled in a particular time is called speed. So now let us say it is expressed by distance divided by time. So the total distance covered by time. So it is a scalar quantity. So speed is a scalar quantity. So it has got only magnitude. Always remember it has got only magnitude. And the SI unit is what? The SI unit is meter per second. How do we get it? The SI unit of distance is meter and SI unit of time is second. So from that when we divide for speed we get meter per second as SI unit. Okay. Now you see what is uniform speed? If an object covers equal distance in equal intervals of time, howsoever small these intervals may be, the speed is said to be uniform. My dear students, please remember that at every interval of time, if you see, it is traveling equal distances. So let us say at t1 it traveled 2 meters. At t2 it again traveled 2 meters. At t3 again it travels 2 meters. So you see t1 it traveled 2 meters, t2 it traveled 2 meters, t3 again it is traveled 2 meters. So there is an uniformity in its traveling. So that is why we say it is said to have a uniform speed. Okay, is that clear? So now let us say if you draw a displacement time graph for this uniform speed, what would be it like? It would be like a straight line. Okay, it would be a straight line inclined to the x-axis. So inclined to the x-axis or time axis means we can say that is much dependent upon the time. Okay, so it is much dependent upon the time you can say. Now let us what is non-uniform speed. So if an object covers the distance in different distances in equal intervals of time, howsoever small these intervals may be, the speed is said to be non-uniform or variable you can say. So for example, let's say if an object travels at t1 2 meters, at the time interval t1 it travels 2 meters. And when it takes when we take the time interval t2 it traveled 4 meters. Again we take time interval t3 it traveled 5 meters only. Okay, so in the first one it traveled 2 meters. In the second time interval it doubled its distance 4 meters. Again in the third one it traveled only 1 meter. So you see there is no uniformity in the distance travel though the time interval was same. Okay, though the time interval was same, there was no uniformity in its distance traveling. So such a speed is called non-uniform speed. Okay, so if you plot a displacement time graph against it, so what it would be like? It would be like a curve shape. You see, it would be like a curve shape as you see in the image we get. Okay, is that clear for you? So now we will see what is instantaneous speed. So what is instantaneous speed? Instantaneous speed is the speed of an object at a specified point or at a particular point of a depth, path or distance traveled in short interval of time. So you see instantaneous speed. So you are now traveling in a bike. You see. So at a particular point you want to see the speed of your bike. Don't think about its velocity but its speed. So how much speed you took at this point to travel. So for that what you have to do, how much travel you have point distance you have traveled at that point divided by how much time you have taken to travel up to that time. Okay, so that will give you the instantaneous speed. Okay, so you have to see the distance traveled at that particular moment. Okay, at a particular time and divided by the time taken to reach there. Okay, so that will give you the instantaneous speed. So instantaneous speed is equal to distance traveled in the short time interval, that particular time interval divided by that time. So it can be represented as IS is meant what? Instantaneous speed is the delta D by delta T. So delta means what? The change in distance divided by change in time. And it also represented by delta X by delta T or delta S by delta T. So delta X and delta S are all the distance we replace with D. Okay. Now see what's the average speed. Average speed of a body is defined as the ratio of the total distance covered by the body to the total time taken. So you see, we say sometimes for example, I took average speed of 60 kilometers per hour. Okay. How do we say that? 60 kilometers per hour. So when you start from the home, you may be starting at 20 kilometers, 40 kilometers. On the way, you may reach 60 kilometers. You may be having at 80 kilometers. And when you reach the destination, you may be again reaching in the 40, 50. Okay, there may be variations. So how do you find the average speed you use to reach from home to your destination? So you measure the distance from your home to the destination and divided by the time taken to reach from home to the destination. That will give you the average speed that is used by you in order to reach the destination. Okay, is that clear? So average speed is equal to total distance covered by the total. So now let us see velocity. Velocity is what? Velocity is the distance traveled by an object in a particular direction in unit interval of time. So you remember velocity is what? Velocity is a distance traveled by an object in a particular direction. So there is one important word, particular direction, in its unit interval, time interval. So velocity is equal to displacement by time. Speed is what? Distance by time. Okay, always remember speed is distance by time and velocity is displacement by time. So there is direction. So what is the beginner? So velocity will be a vector quantity and it is SI unit is meter per second. So because displacement is also meter, time is also second. So the SI unit is same, but it is velocity is a vector quantity. So velocity means it is always the distance traveled in one direction at a particular time interval. Remember that. So usually it is represented by what? It is represented by we can say V, the V with the arrow on the top. Usually we represent with V with the arrow. But when there are two velocities, initial velocity and final velocity, we represent like U as the initial velocity and V as the final velocity. So that we will learn in the further classes, okay, in detail. Now let's see what is uniform velocity. Uniform velocity is a velocity of an object is said to be uniform if it covers equal displacements in equal intervals of time, however small the intervals may be. So you see, it is when you take an object, it travels from one point A. So from the time interval T1 in one direction, okay, always in one direction, okay, it travels in one direction, same direction. 2 meters you say, 2 meters. If the displacement traveled was, the shortest distance between that point was 2 meters and in one direction. So next T2, time T2, the displacement, the shortest distance was again 2 meters. So in the same direction, again the T3, in the same direction, the shortest distance or the displacement was 2 meters. So you see, all the time day durations we had, the displacement was 2 meters. So they are having a uniform displacement. So, and in the same direction. Okay. So the object is said to be having a uniform velocity. Now you see non-uniform velocity. What is non-uniform velocity? Velocity of an object is said to be non-uniform if it covers unequal displacements in equal intervals of time. So, if an object is traveling from one place to another place in one direction, but what happens? They are having what happens at time t1 interval. It may be taking 2 meters, but in time 2 interval, what happens? The displacement becomes 3, and time 3 interval, what happens? The displacement becomes 5. So there is a non-uniformity in the distance covered, or displacement, sorry, not distance covered, displacements covered. So the displacement is not uniform. So such an velocity is called non-uniform velocity. So now let us see what is instantaneous velocity. So instantaneous velocity of the object at a particular point is of its path. Instantaneous velocity of an object at a particular point of its path. Okay, or a particular instant of time. So when you take the velocity of an object at a particular time, that velocity is called instantaneous velocity. Okay, so that velocity means the distance traveled by the object in a particular direction. So when the object is traveling in a particular direction, we take the velocity at that point. That is called instantaneous velocity. Now say, you see this is a circular path. You say displacement is 0. You know the displacement in a closed path, the displacement is 0. But there is instantaneous velocity, because you see in each direction there is velocity in, there is a different velocity at each point. So there is velocity, instantaneous velocity at each point is different. Okay, it is not same. Okay, is that clear? Now let us see average velocity. The average velocity of an object is equal to the total displacement divided by the total time taken. So in order to find out the velocity, average velocity taken by a body to reach from A to B, is that we divide the total displacement of the A to B point divided by the total time taken to reach that point. Okay, so let us say an example. I will show you an example. So the formula for it is average velocity is total displacement by time taken. Let us look into the image. So a body starts to travel from A to B and B to C, then back to B. So the distance between A to B is 10 kilometers, and it is time taken is 2 minutes. And B to C is 20 kilometers, and distance time taken is 4 minutes. The same time is taken to travel back and the same distance. So now let us see. So A is called what? A is called the initial position, and B is called what? The final position, because after completing the movement, it comes to rest at the position B. That is why B is called the final position. So displacement is what? The shortest distance between A final position and the initial position. So that is A and B, that is equal to 10 kilometers. Okay, so displacement is that shortest distance between final position and the initial position. So that is A and B. So that is 10 kilometers. And now that is can be written as 10,000 meters. Okay, 10 kilometers is 10,000 meters. So now total time taken to travel means how much time it taken? First we travel from A to B, that is 2 minutes. Then B to C, 4 minutes. Again C to B, again 4 minutes. So the total time is 10 minutes, that is equal to 600 seconds. So the formula is what? Average velocity is equal to total displacement by time taken. So that is 10,000 meters by 600 seconds. So that is equal to 16.66 meter per second. So that is the average velocity that is taken by the body to complete the displacement. Okay, clear? So what are the difference between speed and velocity? So what are speed? Let us see what are the highlights of speed. Speed is a distance traveled per second by a moving object. Okay. So it is only just simply we say the magnitude traveled by the object per second. So it is just only a scalar quantity and it does not tell about a direction. And the speed is always what? Speed is always positive and doesn't depend upon the direction. It doesn't consider the direction. And after one round in a circular path, the average speed is not zero because there is some sort of movement or distance in the circular path. So speed is not zero. Always remember. But in the case of velocity, the distance traveled per second by a moving object in a particular direction is called velocity. So the distance traveled by an object in a particular, there is direction in velocity. So that is a vector quantity and it tells us that speed as well as the direction. Okay. So velocity will tell us what? It tells us about the speed as well as the direction. So velocity can be positive as well as negative depending upon the direction. Always remember, it is always depending upon the direction. And finally, after completing each round in a circular path, the average velocity is zero. You know, in circular path or closed path, the displacement is zero. So what happens? The average velocity also will become zero. So I hope this is clear for today's class. So my dear students, please kindly take note of the points because these are important points for your further higher studies. So we will again move on to the next chapter. So today up to this much, you try to understand, reread the topics and better acquainted with the topics. Thank you, students.